ABC is an equilateral triangle. D lies on BC. AD is perpendicular to BC. Prove that triangle ADC is congruent to ADB. Okay, so we can say that we know it's an equilateral, so this side will equal this side, which will equal this side. We also know that this angle here will equal this angle here, will equal this angle up here. So there are several ways we can do this. So if I write statement and reason, first method I'm going to say is that AB, so AB on the left there, equals AC. Okay, and then say given, and then in brackets equilateral triangle. Okay, then I will say that AD equals AD, the center. I'll say that that's shared, or you can say common. It's going to be common in both triangles. And then I can say that ADB, angle ADB, equals angle ADC. And that is given initially. Then you can put 90-degree angle. So if I look at these three here, I've said that this side is the same as this side. Okay, so I've got the side. I've then said that AD equals AD, so they share this centerpiece. So that's again another side. And last, I've got this angle here is shared with this angle here. So if I have a look at that, that's an angle. Okay, now be very careful because this does look like arse, which does not prove congruency. But if you have a look, we have the right angle, which is this one. So right angle. We have AD equals AD, which is the side. And the AB equals AC, they are in fact the hypotenuse. So for our congruency proof here, we actually have RHS. Alternatively, if I just get rid of this, we can prove it in another way. So let me write over on the left hand side now, statement, let me just put number 2 and reason, because it really depends on how you look at these questions. So again, let me just mark on the triangle, equilateral, 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 angle, angle, angle. Okay, so on the left there we did RHS. Let's look at another way of doing this. So we could say that AD equals AD, and then shared, and that's really given. Okay, so that's this centerpiece. Then we could say that angle ABD, so that's this one right here, okay, which is 60 degrees, equals this one here. So that would be ABD equals ACD. That would be for equilateral triangle property. And that would be from an equilateral triangle property. So let's put 60 degrees there. So we've got side angle. What else could we do? We could then say that AB equals AC, and that would be another equilateral property. Okay. And if you look here, that would be side angle side. Okay, so there's just two ways of doing it. There are a few other ways too. Okay, so if we know that from above the two triangles are congruent, that would mean that BD equals DC. Okay, and that's from the congruency we just proven above. So if they are both congruent, that would mean that BC, so the entire bottom of the triangle, would be equal to AB. So if the entire bottom would be equal to the entire length of AB, that must mean that the length of BD is half of AB. So our main proof was up in question A, and what we need to do here is finalize it. So let me just run through this again. We've said, and I'll try and highlight the area. So we've said that BD, so this length here is, I'll try and highlight here. So BD is the equal to DC. We proved that from the congruency above. Remember, it means they can fit on top of each other, congruency. So BD equals DC. Now, if those two equal each other, that must mean that the entire length here of BC, okay, here, entire length of BC is equal to AB, okay, which is here. And if that is true, that would mean that BD, so BD here, is 1/2, so half of the length of AB.